Grace and peace to you all, and welcome back to my channel. This is Donald C. I'm an author of A Hidden Mathematical Genius Within Revealed. Okay, so today's question is on parametric equations. Parametric equations is an application of calculus and differentiation. Okay, so here's the question. The parametric equations of a function are given by y is equal to 3 cos 2t and x is equal to 2 sin 2t. Determine the expression for dy dx. Okay, so we want to find an expression for dy dx, and we have two functions. The two functions we have it's y 3 cos 2t and x 2 sin 2t. From this function y is equal to 3 cos 2t, we can get derivative of y with respect to t. And here we have x is equal to 2 sin 2t. Okay, so from here we can get x, derivative of x with respect to t, or derivative of t with respect to x. Okay, solutions. Okay, so we want to find dy dx. So dy dx will give us, so according to the functions we have, we can have dy dt times, now here we can think of these as fractions. So we have dy dx is equal to dy dt times, so the only way we can have dy dx is when we have here dt over dx. Okay, so you think of it as fractions. If we have dt here, the dt can cancel out with this dt, so to speak. Yeah, then over dx. Then we can remain with dy dx. So from the first function, that is y is equal to 3 cos 2t, we are going to find the derivative of y with respect to t. Okay, so you say y is equal to 3 cos 2t. Y is equal to 3 cos 2t. So derivative of y with respect to t. So you say dy dt is equal to, okay, so what is the derivative of 3 cos 2t? So we start with 2t, derivative of 2t with respect to t, we will get 2. So 2 times this 3, we are going to have 6. Now, derivative of cos. The derivative of cos is a negative sign. So derivative of cos 2t is equal to negative sin 2t. Okay, so that negative you multiply by 6, so it will be minus 6 sin 2t. Okay, so that is the derivative of y with respect to t. Okay, we go to our second function. Our second function is x is equal to 2 sin 2t. Okay, so this one we are differentiating it with respect to x. Okay, we are differentiating with respect to x, so that we come up with dt dx. So what is the derivative of x with respect to x? Okay, so that is a 1, yes. So we have 1 is equal to what is the derivative of 2 sin 2t? Okay, so we start with 2t, derivative of 2t, you get a 2. 2 times 2, that is 4. So we have 4. Derivative of sine is cos. So derivative of sine 2t, you get cos 2t. Now, since we are differentiating this with respect to x, we'll say this times dt dx. Okay, then we need to make dt dx the subject of the formula. Okay, so if you remain with dt dx here, it means we have to divide 4 cos 2t throughout the equation. So we are going to have dt dx is equal to, you divide 4 cos 2t throughout, so 4 cos 2t over here, it will cancel out this 4 cos 2t, and this side we are going to have 1 over 4 cos 2t. Okay, so we have our two derivatives, that is dy dt and dt dx. Okay, so therefore dy dx is equal to okay, so dy dt we had minus 6 sine 2t, then times dt dx we have 1 over 4 cos 2t. Okay, then we say dy dx is equal to can say minus 6 2t times 1, that is minus 6 2t. So we have minus 6 sine 2t. So minus 6 sine 2t over 4 cos 2t. Okay, so this is equal to sine 2t over cos 2t will give us tan 2t, because sine over cos is equal to tan. Okay, so sine 2t over cos 2t, you get tan 2t. So we are going to have minus 6 over 4 tan 2t. Okay, dy dx is equal to, so you can simplify here. The highest common factor for 6 and 4 is 2, so 2 in 6, that is 3, so we have minus 3 over 2 in 4, that is 2, so minus 3 over 2 tan 2t. So that is our expression for dy dx. Thank you so much for your time.